All right, guys, in 7.2, we're going to be solving some different types of what we call exponential equations. And an exponential equation is literally just an equation where you have variables in the exponent position. All right, so the ones we were graphing yesterday, like b raised to the power of x. There was an exponent that was a variable. So that's the only definition that we're going to be working with here. So property of equality is something that we're going to be working with. And we start by saying this. We need to have a base that is greater than 0, so it has to be positive, but it can't be 1. All right, so when you're dealing with a base of 1 would be absolutely nothing, because 1 raised to the x would just be 1 over and over and over again, and it has to be a positive number. So we start with that. And then if we know that this thing is true, so like if we have b to the x is equal to b to the y. So if we've got this equation where the bases are the same and then you have different variables as exponents like that, then it must mean that the exponents are the same. Okay, so if you can get it to look like this, then you know the exponents must be equal. Say we had like 2 as a base. The only way that 2 cubed is equal to something is if it's 2 cubed. Like 2 cubes can't be equal to 2 to the 4th. So if the bases are the same, the exponents must be the same if you've got those two things set equal to each other. So in order to use that property, what we're going to do is make sure that the bases are the same. So if we look at example 1 part A, for instance, 3 raised to the x, that's a base of 3. What we want to do is make sure that our bases are always prime numbers. So on the left, 3 is already a prime number, so that side is good to go. So we're just going to leave the left side exactly as it is. On the right-hand side, our base is 9. 9 is not a prime number. So if our base is not a prime number, we want to write it so that it is. So 9, if we write it as a prime to a power, we can write 9 as 3 squared. So we replace the 9 with a 3 squared, and then don't forget you still have that exponent of 4 on the outside. All right, so we're going to simplify that right-hand side. Left-hand side is staying exactly the same. What I have is this property that tells me I can multiply. If I have a power raised to a power, I can multiply the 2 times 4. So this is 3 to the 8th. So now we can follow this exact property right here. If my bases are equal, that must mean that their exponents are equal. So we've got an x on the left, 8 on the right. That must mean that x is equal to 8. So that means that 3 to the 8th is the same number as 9 to the 4th. And you can always check that. Like we could plug it into our calculator really quick and I could show you. So if we have 3 raised to the 8th, that gives us 6,561. If I had 9 raised to the 4th, it gives me the exact same number. So you can kind of just check your answers really quickly that way. Okay, we're going to do the same thing with part B. On the left, 2 is our base. 2 is already a prime number, so that side is set. On the right-hand side, however, we have a base of 4, which is not prime. We can write 4 as a power of primes, though. We can write it as 2 squared. So replace the 4 with a 2 squared, and then you still have that 2x minus 1 as its exponent. Okay, so this one's going to be just a little bit more complicated. We use the same property that we used right here. We multiply exponent times exponent, which in this case means I'm distributing that 2. So distribute the 2, I will have 4x minus 2 as my exponent. So with this one, I'm going to be setting up a little equation. Since the bases are equal, I know the exponents must be equal. So I can set up this little mini equation and then just solve for x. So I will be subtracting the 4x from both sides. So I have just an x on the left, and then I end up with a negative 2 on the right. So x equals negative 2 would make these two sides of the equation equal. All right, so that's our first type. Second type of problem we're going to be looking at is setting up our own exponential equation. So when they tell us to write an exponential function, the sort of generic function that we're going to be using looks like this. So we've got a coefficient out front, we have a base, and then our exponent. So they're going to give us 2 different ordered pairs, and you'll see problems like this in your homework as well. 2 ordered pairs, and we're going to be creating the function ourselves. So it says in 2000, the population was over 1 million, 1.3 million, and then 2007, 7 years later, it was 1.5 million. So we are going to write x in terms of the number of years since 2000. So what you do with these problems is either they will give you ordered pairs or you're going to write them yourselves. So first ordered pair is 0 years since 2000, and the population was 1,321,045. And then our second ordered pair is 7 years later. The population was 1,512,986. Okay, so we are going to use those two equations to come up with, those 2 ordered pairs to come up with an equation. So we do is one after another. We're going to plug first this ordered pair into this equation, and then we'll plug this ordered pair into this equation. So you'll see what that will get us. So first we're going to plug this in. So 0 is our x value, so that's going to get plugged in right here. And then the 1.3 million is our y value, so that's going to get plugged in here. So that's the first thing we're going to do. Plug in this very large value for y. We don't know what a is yet. We don't know what b is yet. We're plugging in a value of 0 for x. So b to the 0 is just 1. Okay, so knowing that this is just 1, that means I now have my value of a. I now know that a is equal to 1.3 million. So now I can rewrite this equation because I know what a is now. So I can write y equals my new value of a, but I still don't know what b is. So now I'm going to use this second ordered pair to solve for b. All right, so I'm going to plug this in for y. So that was 1,512,986 equals 1,321,045. I don't know what b is, but I do know that x is now 7. So b is going to be the last thing I solve for. Once I get that, I will then have my equation. So I'm trying to get this b by itself, so I will divide by this lovely large number here. Your homework problems will have more pleasant numbers than this. So it'll cancel from the right-hand side like that. So I will plug in 1,512,986 divided by 1,321,045. Oops, of course they give me a fraction. I will get this. Okay, so I want to write all those decimals down. 1.14529. And that is b to the 7th. So to get rid of the 7th power, I will take the 7th root. So I'm going to take the 7th root of both sides. And this, of course, my calculator will be doing, and then I will have the value for b. So I'm going to say Control, and then hit this little caret key. So I can type the 7th root in there, and then 1.14529. So that is my value of b. So about 1.01957. Okay, so I will have y equals, so I now know my value of a is 1,321,045, and then b is this nice decimal value that I just got, and then raised to the x. So that is the equation that we were looking for in that part. And then we can use that equation to predict the population in 2013. So we are going to try to find y. Basically what this is asking us is to find y if x equals 13. Because remember, we're saying x is years since 2000, so it's been 13 years. So we're going to plug 13 in here and just type that into our calculator. So we'll have y equals, again, this lovely equation with all the big numbers. Like I said, your homework problems will have nicer numbers than this. Okay, we're raising that to the 13th power, so I'm just going to show you how to type that entire thing into your calculator. So you'll have 1,321,045. In parentheses, I'm going to put this base, and then that little caret key, a couple buttons over from the 4, and you'll be able to type in an exponent of 13. So that is our estimated population. And this is scientific notation. So it means you move the decimal over 6 decimal places. So that will be 1,699,000 and then 570. Okay, so that is our approximate population in 2013. I think I'm going to save the rest for part B.